is. Good. Now let us look at how we are supposed. So here they are having AB. So we are not far away from what they have done. This time the bigger one is down, which they gave B for us, the bigger one is down, which I've given A. So no problem, still the same thing, as long as we shall get the same answers to our question. So I don't want to look at the answer, but I want us to do this in our own way and get the answer. So we have finished extracting out the triangle APQ. So the next thing that we are going to do is we are going to put that line AM that you have already drawn in the first figure. So we draw line AM. Now that line AM that I'm drawing from A to M bisects this angle into two. Like that. So this is point M. Now what you should know is this. You should know that if this was 100 degrees, if the angle here was 100 degrees, so this line I've drawn does not only bisect this PQ into two, but also bisects the angle, divides this angle into two. So it means that here I'll have 50 degrees, and also here I'll have 50 degrees, like that. Okay. Now the other thing is that you should know that this distance PM is equal to the distance PQ. So PM, not here, PM is equal to MQ, and I'll call that X. So I'll call it X. So this is X and this is X, like that. They're equal. So now once I get 1X, I'll be able to find the answer of the length PQ. So what I'm going to do is I'm going to extract out the triangle. So work with triangles everywhere. So using triangle. So let me say using triangle, that one is triangle, using triangle. Let us use APM. Let us use triangle APM. That triangle, and that triangle is right angled. Why? Because this line here bisects anything, any line that bisects another line into two equal parts meets it at 90 degrees. So that is 90 degrees. So I'm drawing line APM. So I have like that. We'll draw this. We'll draw that, and I'll have APM. So this is X. Remember, my distance here is 6.5 centimeters, and my angle, which is here, is 50 degrees. Now I'm going to find X. What I want is to find X. So I can use this thing that you use, and from there I can select what should I use to find X. I'm asking you, what should I use to find X? Members, are you eating? What should I use to find X?
Sine.
We use sine.
Yes.
Okay. We use sine. So sine 50 equals to the opposite over the what?
The hypotenuse.
The hypotenuse. Correct. So sine 50. What's my opposite? Remember how I told you to get the opposite, some little I here, put an I here. Let's put the I here. So we put the I there, and this person, the opposite is what he sees, okay?
X.
And he's seeing what? X. So X is the opposite, so right? X out of the hypotenuse, which is 6 point what?
6.5.
6.5.
So I cross multiply from here. There I cross multiply. So I have X times 1 equals to 6.5 sine 50. So what is my X? What's my X? What do you get as X? I don't have it. What do you get?
4.979.
4.979.
79.
So 4.98, isn't it?
Yes, teacher.
Okay, so now the other thing that you see is that PQ is twice X. PQ is twice what? Okay, let me first raise this a bit. If I not see. Okay, from there, PQ is twice what? Is twice X, isn't it? So PQ is twice
Yes,
X.
teacher.
So from there, if PQ is twice X, then we can find the value of PQ, so which is going to be 2 times 4.98. And what do you get?
9.96.
9 point what?
96
9 is?
centimeters. 6.
968.
96.
96
Yes.
centimeters, which is almost 10 centimeters. Oh, we have the same thing, so you can see it is 9.96. Clap for yourselves and clap for me. So we go to the next question. The next question is yours. You are the ones who are going to do it, not me. Have you understood the first question?
Yes, teacher.
Okay, so let us look at the next question. They are saying that two equal circles of radius 15 centimeters or 5 centimeters intersect at right angles. So we write number 2. They're saying two equal circles. You must write, that's why I'm writing, and you must write faster than me. Two circles of radius 5 centimeters intersect at right angles. Okay. They are saying part Roman number 1, find the distance between the two centers of the circle. Find the distances between the two circles. Roman number 2. They're saying calculate the area of the common region of the circles. Calculate the area of the common regions of the circles. Okay, trying to fix this a bit.
Teacher,
Yep.
if they bring such a question in the exam, will they draw for you the circles or they don't?
They may not draw it for you. They may draw to make your work easier, but they may not draw. So you must learn how to draw it. Yeah?
Yes.
So can we draw it on our own? Sorry, it is already shown. Let us draw it. Let us draw it on our own and then see. So if they are saying two equal circles, two equal circles of radii, I think I missed it there. Two equal circles of radii, this is not there, of radius, 5 centimeters, intersect at right angles. So we are going to draw two circles which have the same radius intersecting at right angles. Wow, this is nice. So let us draw the first one. When I do this one, I must make sure it is big because my calculations, I need to see what I'm going to calculate. Okay, that's the first one. The distance apart somewhere. Okay, like that. So those are the circles with the same radii. And call this one, I can call this one center O1, sorry, O1, O2. Okay, there are two circles there, intersect at right angles. Intersect at right angles. Then they're saying find the distance between the two centers. They intersect at right angles. Why does that one mean? So you should know that these two circles have radii. So let me first do the first one. Its radii is here. Okay, and the second one, its radii is here. Okay, one is red, another one is blue. I think you can see there very well. Now, the angle between these two lines here is 90 what? Is 90 degrees. Are we together? We are seeing this angle here is 90 degrees. So you intersect at right angles. That angle there is 90 degrees. That's what they mean. Okay, so I'll complete. I'll put the other one, this other radii here. That, and then this other one here. Like that. Now, what do they want? Find the distance between the two centers from here up to here. So the other thing that you should know is that those two circles have got a common chord, and the chord is, let's say this is P. Call it P again, and this is Q. So they have a common chord PQ, and I'll draw a common chord PQ using my pencil from here up to there. That is PQ. That's the common chord. But they don't want PQ, but they want the distance from O to O2, O1 to O2. That's the distance that they want, because they're saying find the distance between the two centers. Wow. They want this distance. So let me use dotted lines so that we don't create a lot of put their arrows for you to understand what they want. They want that distance from, okay? But remember, all of them have 5 centimeters. Like that, isn't it? Now, which angle do you think is here? Members, unmute. 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 And answer to me. Which angle do you think is here? It is what?
90 degrees.
This is R2, this is R2, this is R1, this is R1. So the angle between R2 and R2 is 90 what? 90 degrees, isn't it? So it means that this is, and which angle? Okay, here it is 90 degrees. And also here it is what? 90 degrees. Okay. Now, we want the distance from here up to there. So they want O1. So they want O1. They want that distance, O1, O2. That's the distance they want. So for us to find that distance, now this line we have drawn here, it bisects this PQ at point M. Isn't it? That is M. Okay. So we are going to find, what you should know is that, before I tell you what we are going to find, what you should know is that from here up to here, are we together? From here up to here is the same as from here up to where? Up to there. Why? Because these are circles of the same radius. Circles of the same radius. So it means that distance from here up to here is the same distance from here up to there. So if we find this distance from here up to here, all this distance from here up to here, we shall just multiply it by 2 to get the distance from here up to there. So let us use triangle. So using, can say use triangle, we are going to use triangle PQO1. So PQO1. PQO1. That's the circle we are going to use. So I will extract it out and we shall have this. Need it when it's big enough for me to see what I'm drawing. So this is O1 there. The angle which is here is 90 degrees. It's 90 degrees here. Then this is P, this is Q. Okay. This is 5 centimeters. This is also 5 centimeters. Now, the distance I want is this one here, O1M. So I'll draw here. I'm drawing this line from O1 to M. Is what I'm drawing here, from here up to here. So here I have Are we together?
Yes.
So it means that this angle, which angle is here?
45.
45, correct. So 45 degrees. Okay, so this is 90 this side. So I want to get to this distance here. So I can extract out a triangle O1 PM. Bambi. Wilima. Okay. Okay. Let us extract out that triangle. Okay, so I have P here, I have M, and I have O1. So I know this is 45, and this is 5. Okay, now how do I get, because I want to get, if you look here, I want to get, my camera is shifting. I want to get OM, because OM, this distance here is equal to this distance. They are equal. So if I get, zoom in there for you to see. So if I get OM, I multiplied by 2 to get O1 or 2, this distance in between. So I'm getting O1M, this distance. So to get that distance, that's why I have to use this triangle here, PO1Q, this triangle here. And then the sides are equal. So I'm going to use only this triangle, which is here. I know this angle here is 40 what? 45. So that's why I extracted out to that triangle O1PQ. And now I've extracted a triangle O1PM to find this distance O1M. So what am I going to use O1 to find this distance O1M? Let us call it X. Let's call this distance X. So how do I find X? What am I going to use? Okay, so what am I going to use from there?
For me, I used.
I'm not hearing you.
Me, I used.
Let me ask someone. Olivia, what are we going to use?
Sine.
We are going to use what?
Sine.
We are going to use sine to find X. Are you sure? What are we going to find there? Is it sine? Letitia, keep quiet. Letitia, keep quiet. I'm asking. What are we going to find? Now it is that Cynthia. What are we going to use? Cynthia. Cynthia. Wait, stop sleeping. I'll come and move you from the bed sheets. Cynthia, what are you going to use? Cynthia, are you there? Cynthia is taking seat. Let me ask my friend. Wendy, what are we going to use?
Tan.
We are going to use tan.
No.
Darius.
We are going to use.
Yes, Wendy. We are going to use what?
Cosine.
Yeah, cosine.
Members, stop deceiving one another like that. What are we going to use, members?
Cos.
Cosine.
We are going to use sine.
Cos.
Why are you saying cos? Things of colors
X
answer.
seems to be the
Because
X
you're looking
seems
for
to be the
the
adjacent.
adjacent.
X is what?
You're
Adjacent.
looking for the adjacent.
Okay, when I look at this angle here, which one is opposite? Which side is opposite? This
PM.
is the I. Which side is opposite?
PM.
PM. So this is opposite. Which one is the adjacent?
X.
X. So this is the adjacent, and this is the hypo. So what are we going to use? Let me ask someone here. Wilma, what are we going to use? Wilma? Wilma is babysitting. Okay. You were right, we are going to use cos. I just wanted to find out. Some of you are there doubting now, what are we going to use? You are scratching your head, scratching their stomach, what and what. We are going to use cos. So we shall say cos of 45 equals to the adjacent over the hypotenuse. So cos of 45 equals to x over 5. And then we can find x equals to 5 cos of 45. So 5 cos 45, what do we get? 5 cos 45, what do we get? Yes? So x equals to 5.
3.5.
We get what?
3.53.
2 decimal places. 3.5.
3.53.
3.53.
3.
3.
Like that. Okay, 3.53. Now let us go back to our diagram here. So this diagram, this distance here is that which I found, which is x. But that distance which I found x, it is also equal to this. So that means that we have to add x plus x to get the distance between the centers. So the distance between the centers now becomes, so O1, O2 is 2x, which is equal to 3.53 times 2. And what do you get? What do you get?
$7.06.
7.0 what?
6.
06.
7.07. 0607.
6.
06.
06.
Okay, 06 centimeter. Okay. So here they have 7.07. Now, can you imagine we have gone through quite a big step? Because here, if this is 90, if this is 90 degrees, then we use Pythagoras theorem and we say a squared plus b squared is equal to this. And that's what they used here. And they got 7.07, which is not far from what we have done. So that is another alternative whereby you can use Pythagoras theorem. I've just seen it there in the answer. So it is this squared plus this squared, because this is 90 degrees. This is a right angled triangle, this one here. Yeah? It's a right angled triangle. So you can say 5 squared plus 5 squared equals to PQ squared and also get the answer. Okay. So you can say or you can have, you can say PQ squared equals to 5 squared plus 5 squared. It's 25 plus 25, which is 50. So the square root of 50 is what they want, which is 7.07 centimeters. So that is also another way how you can get PQ. All right. Now, the other question was to calculate the area of the common region. Calculate the area of the common region. What is the common region? Let me show you the common region. This is the common region here. This area here is the common region, this one here. So how would you find that area? How would you find that area? How would you find that area? So to find this area, I'm going to just draw only one circle there. Only one circle, and then we find the area. So I'm drawing only one circle, and then we find that area. So we have already done this. when you're looking at area of where we have area of a sector minus area of a triangle, that's what we are going to do. So let me draw only one circle there. And I put that this was 5 centimeters, even this one was 5 centimeters there. Let me call this one down with O1. So 5 centimeters, 5 centimeters. Now I put the common chord is here, which is PQ. So the other circle also passes somewhere here like this, but for it, they share the same chord here. So let me show you what I've drawn. Maybe when you look at this in the book here, I've drawn only this circle with A. Let me call this one A. This circle here, this one here. Okay. Only that circle. And now I've drawn a line P to Q. That's the line P to Q. This line P to Q. So I have to find this area here. I have to find that area. How do you find that area? How do you find the area of that shaded part? So you have to get the angle. You have to know the angle which is here. So the angle which is here, we said that it was 90 degrees. So I have to find the area of the whole sector. Then minus area of the triangle. I don't know whether I remember that. Do you remember that?
Yes.
So area of the whole, So some of you are not there. So you have to find the area of the whole sector minus area of the triangle to find this. So let me just give you the steps and then you do it on your own. Because next time we want to do another topic on what? On Thursday. So I've just drawn on this circle here. So I'm looking at this part here. Let me shade it here for you to see it. This part here. Okay, this part here is what I've drawn in the other circle. This is the part here, PQ. So it is only this part here which I've drawn here, this one. So if I find this part here, this shaded part which is here is the same as this part here. So they are equal. Why are they equal? Because they are circles of the same radius. So what you need to do is to find this shaded part and find its area. When you find its area, just multiply it by 2 to have the area of the whole of this. So we have to go and see how do we get this part here? Only this part. And that part is what I've drawn here, PQ. Maybe I can show you that if I put the circle like this, it can bring out what I'm talking about. So this is the part that I'm talking about, this one here. Okay. So now for me to find this, I have to find the area of the sector. What is the sector? The sector is the whole of this. This is the sector, this one here. The whole of this that I'm painting red, that is the sector. The whole of this, that is a sector. And then minus the area of the triangle. Okay. So we have only 2 minutes. Maybe I can just outline the formulas and then you finish. So to find this area of the shaded region, which area of the shaded region? I'm talking about this area here. This is the shaded region, this one here. Okay, to find this area of the shaded region, I have to find the area of the sector, then minus area of the area of the triangle. Okay. So area of the sector, it takes the whole of this. This is the sector. This pizza thing here, this one is the sector. This one, this is the sector. The whole of this is a sector. That is a sector. So area of the sector is given by theta out of 360, then times pi r squared, then minus area of the triangle. Now this triangle which is here, this triangle. So the area of that triangle is given by a half times r sine of the angle theta times r. This is r, this is r. Sine the angle theta. That angle there is theta. So you substitute and you put 90, because the angle here is 90 out of 360, then times 22 over 7, then times the radius, which is 5 squared. This minus a half times r squared, r times r is r squared. So that is the same as 5 squared. Then times the sine of 90. So you do that and you get out the answer. Now that answer that you get, to get the area of the whole of the other shaded parts, we multiply this answer you have got here times 2. And we get the area of this, the whole of this part that is here, the whole of this part here, this part here, the whole of this. We multiply it times 2 and we shall have the answer. So I want you to do that and finish up, and you check in the book and you check whether you have the same answer as 14.25. If you don't have that, you repeat again until you have that. So you go and pick any exercise that you want from here. Pick any